Good morning, everyone. Welcome to what I think is the most rewarding moment of cars, phase number 5. This is the phase where everything we have studied through the semester finally comes together. All those equations, all those propagation parameters, all those reflection coefficients, all those Smith chart rotations. They stop being abstract symbols on a page and becomes tool you will use to address a real problem in your community, your country, in the world. Today, I want to walk you through this phase in detail. Share screen. In detail. So when you leave this session, you know exactly what is expected of you, how you will be evaluated, on how to deliver work that you can be proud of. Let me organize my explanation into three big blocks. First, I will explain the learning guide for phase number 5, the one that you have in the screen, which tells you what you must do. Second, I will explain Appendix number 5, the delivery format, which tells you how your final product must look. And third, I will explain the Evaluation Rubric, which tells you how your work will be granted, and the fourth, where you should focus your effort. The phase number, the step number 1. Okay, this is the understanding the learning guide for phase number 5. Let us begin with the basics. Obviously, phase number 5 is the final evaluation moment of the course. It is an independent activity, meaning each one of you will work on this individually. There is no collaborative component, no group submission, no shared document. You are the sole author of your work. This activity is worth 125 points, which is a significant portion of your final grade. It opened on Wednesday, May the 13th, and closes this Tuesday, May 26th. You have you have had approximately 2 weeks, and the guide estimate close to 6 hours of independent work. I want you to emphasize something here. Those 6 hours are a minimum estimate to someone who already had a clear idea in mind. If you want to produce excellent work and the rubric rewards excellent work, you should plan to invest more time, especially when it's research and design. The three learning outcomes of this guy are integrated and presented in the screen. Phase number 5 doesn't focus on a single learning outcome. It integrates all three learning outcomes of the course. Learning outcome number 1 asks you to understand electromagnetic theory concepts through problem solving in a wave propagation in open media, classifying behavior based on parameters that affect propagation. And this is what we have covered when we discussed waves traveling field freely through the air, vacuum, and other unbounded environments. Learning outcome number 2 asks you to apply the principles of reflection, refraction, and Snell's law to analyze and predict the behavior of electromagnetic waves in confined media, what we did practically in phase number 3, when we calculate reflection coefficients, transmittance, and the angle across the air glass air interface. And the learning outcome number 3 asks you to evaluate the propagation of electromagnetic waves in guided media by calculating electrical and propagation parameters using mathematical models and the Smith chart. Exactly what we did in phase number 4 with coaxial lines, input impedance, VSWR, and the online Smith chart simulator. So phase number 5 is not asking you to learn something new from scratch. It is asking you to demonstrate that you have internalized all these three outcomes by applying them to the real social and environmental problem. What exactly you are building? The core deliverable is described very clearly in the guide, which is elaborate a poster that identifies a social problem and proposes a solution based on technologies applying the principles of the wave and electromagnetics. Read that sentences carefully because it contains the entire activity in one line. There are 3 elements: a poster, not a slide, not a report, not a presentation with multiple slides. It's a single poster in a IEEE format suitable for an international scientific event. Number 2, identification of a social or environmental problem, something that is real, something that matters to people. And number 3, a proposed solution using technologies that apply the principles of waves and electromagnetics. And this is the technical heart of your work. The reference that you could use for inspiration are the following. There are 4 key and somehow academic references, and I want you to look them carefully because they are not random. Each one is a concrete example of how wave and electromagnetic technology solves a real problem. For instance, the first one addresses a real problem, which is the miners are working underground, often lose communication because radio waves cannot reach around the corners. The solution applies metasurfers, engineering electromagnetic structures to redirect signals. This connects directly to reflection, refraction, and wave propagation in a confined medium. Number 2 addresses the problem of monitoring bridges, dams, and buildings for structural health. The solution uses electromagnetic waves, radar, GPR, microwaves, to measure the formation and detect damage before catastrophes occur. Number 3, this is a Colombian paper published in the UNAD journal. It addresses the problem of measuring temperature in extreme industrial environments. The solution applies antenna theory and substrate analysis. And number 4 addresses the problem of electric vehicle range, anxiety, and charging infrastructure. The solution applies electromagnetic induction and resonant components. That means the pattern. There is a problem, there is electromagnetic technology, and there is a solution. The poster must follow the same logic. You don't have to choose one of these 4 topics. You can, they are excellent in starting points, but you are also free to identify your own problems. Some areas worth exploring include 5G coverage in rural areas, electromagnetic interference in hospitals, radar systems for landslide detection in the Andes, satellite-based agricultural monitoring, Wi-Fi accessibility in underserved communities, biomedical applications like MRE and microwave hyperthermia, electromagnetic shielding for critical structure, or wireless sensor network for environmental monitoring. The list is quite enormous. Choose, choose something you genuinely care about. Your enthusiasm will show in the final product. So these are the 5 steps covering the guide. Step number 1 is review the academic resources. Do not skip this. Read at least 2 of the 4 papers in length and in depth. This will give you both a modelic scientific writing and a sense of how electromagnetic principles connect to application. Step number 2, download the appendix number 5. We will discuss the template in detail in a moment. And number 3, and notice the guide skips from 2 to 4, but it's intended. Step number 4, elaborate the poster, clearly identifying the social and environmental problem and representing your proposed solutions. And step number 5, 3 days before the activity closes, submit your final work as a PDF in the evaluation environment. Submission requirements, basic, the fully completed poster template, every section filled in, no placeholder text remaining, at least 5 references in IEEE format. This is a strict requirement that previous classes, which only asked for once reference in APA format. For phase number 5, the references must be in IEEE format. That means number reference in square brackets, like 1, 2 brackets, with the specific IEEE citation style. And obviously, the academic situation that I'm considering within the guide. Part number 2, this is the annex number 5, or the appendix, the delivery format. This is where many students lose points because they treat the template as a suggestion rather than as an restricted format specifications. This template is mandatory, as you can see there. The rubric explicitly rewards following the indicated format guidelines. The template is modeled on the format used by the IEEE International Conference on Applied Superconductivity Electromagnetic Devices. This is a real international conference. When you submit your poster, you should imagine that you are about to stand next to as a poster session with researchers from around the world walking out to ask you questions. That mental imaging will help you make good design decisions. The required sections, title, very top, 30-point font bold. The title should be specific, descriptive, and informative. A good title tells the reader the problem, the technology, and the context.